Hi, John Capobianco here. Now that we have everything set up and we have our consensus algorithm working and our AI jukebox, let's call it, using Kubernetes, I thought I would level set, go over the original diagrams and original planning, an updated version of the original planning based on our model selection, and then actually test some packets. Let's test DHCP, BGP, RTP. We'll test a few different packets and see how well it does. We know that 5 out of 6 LLMs that we've chosen, all of them minus the Qwen model, were able to correctly identify the source and destination IP address of a single packet. We noticed that 5.4 is more verbose and gave us a deeper insight into it. It even gave us a source and destination MAC address and the port number at layer 4. And even this DeepSeek model, which is only 3.2 billion parameters at 2 gigabits of disk space versus 5.4 at 14 billion parameters and 9 gigabits of disk space, DeepSeek was able to answer it. Let's try some more philosophical questions. What can you tell me about this packet capture? Is this a secure packet capture? Various questions of that nature to see how well these models do with retrieval augmented generation with the access to the packets and prompts like, what can you tell me about this packet? We're going to run them through each of their individual answers, take all of those answers and send them back to each of the 6 LLMs and do that iteratively a third time till we come to a final best answer that hopefully we can trust, because 6 different artificial intelligence large language models and small language models have all had an opportunity to individually answer, reconsider their answers with more context, and then finally come to a final conclusion on an iterative type situation. So let's take a look at the high-level planning and how this is all done in case you're new. I have done several videos on this. I recommend maybe you go back and check them out, but let's get everyone up to speed. Okay, so the original plans look something like this. As I've described it, we're going to upload a PCAP, do this LangChain RAG process, send each question to, in this case, it was originally 4 LLMs. Now the stack, I have an NVIDIA RTX 2060. It's not a super high-end graphics card anymore. It was when I bought it, but it is not any longer. And I have very, severe limitations on this card. However, from my Windows machine, Windows 11, using Linux via Windows Subsystems for Linux, WSL2, I have Ubuntu, Docker Desktop, and Kubernetes via Minikube. And now I have 6 different Ollama pods, an Nginx reverse proxy, and my Streamlit application, which is the RAG LangChain implementation that we talked about. So here's what it looks like now. We have, can I go to freehand? So the user is going to upload their PCAP and ask a question or a series of questions. These questions are going to go to Gemma 2 from Google. This is 5.6 gigabits in disk and 9 billion parameters. Llama 3.1 from Meta, 8 billion parameters, 4.9 gigabits. 5.4 from Microsoft at 14 billion parameters and 9 gigabits of disk. Mistral from Mistral at 7.25 billion parameters and 4.1 gigabits of disk. DeepSeek, and I'm just calling this from researchers in China. I don't know who to attribute this to yet. This is 3.2 billion parameters at 2 gigs of disk. And then Qwen from Alibaba, 3.9 billion parameters, 9.5 billion parameters, and 2.3 gigs of disk. Okay? So initial answer from each RAG using the RAG process from LangChain, where our source is actually JavaScript object notation. We use a JSON loader. We manipulate the packet metadata a little bit here, transform it into small chunks using a semantic chunker, embed it using OpenAI in the cloud. And I should maybe draw a line here to show that when we're embedding, this goes to OpenAI's cloud embedding service. OpenAI cloud embedding service. And then we store it in ChromaDB for our vector store. Our retriever are these LLMs, right? So there is a connection here between the retrieve and the individual models. Once we have those answers, the consensus answers, we pass the block of answers, right, back to themselves for a final answer. So let's get going here. We're going to select all models, and we're going to upload a DHCP packet capture in this case. And we're going to look at the packet after I ask the question, but we're going to ask a high-level question. What can you tell me about this packet capture? And we're hoping it can give us insights into the fact that it is a DHCP packet capture with 4 packets, including a discover, an offer, a request, and a final acknowledgement. That the source should be 0 until we finally get a source IP for the acknowledgement from the server. So hopefully we're able to get, port numbers, 67, 68, IP addresses, and it looks like there's, 3 IP addresses involved, including the broadcast address. Can these different artificial intelligence, LLMs, large and small, give us some insight into just uploading a DHCP flow and seeing if we can get the inference and the insight and the answers, 1, individually from each model, and then 2, boiling it out into a consensus. And I'm hoping the final consensus knows from each of the models that this is a DHCP flow and some different pieces of information, port numbers, IP addresses, broadcast, acknowledgement, offer, right? So let's take a look. I will pause the video until we have the first batch of answers, and then we'll come back and explore them from each of the different models. Okay, it's still rocking, but check this out. So Gemma 2, this is the Google model, 5 gig or so, packet captures DHCP, sent from 01 to the server. Here's a breakdown of what we can learn. It's got the hardware address, the server address, DHCP message type, some contextual information. Next, we have Llama 3's response, which indicates DHCP. And it kind of goes through the whole process here. This is all very good stuff. Mistral picks up that it's DHCP, UDP, port 67, port 68, heading to the server of, right? Very cool stuff. Qwen sort of doesn't even answer. So I might have to drop the Qwen model. So far it hasn't performed very well, so I think in my next iteration, I'll find another substitute for Qwen in this Council of Oracles. So far I haven't got great responses. 5.4 gives me this super verbose Ethernet layer, IP layer, UDP and DHCP layers, frame-specific details, second packet, observation and analysis. All of this awesome stuff from the 5.4 model. DeepSeek. Let's see how this very small DeepSeek model performs. DHCP message, the correct IP addresses, the correct MAC addresses. Really powerful stuff for such a small model. Now, unfortunately, Gemma 2 timed out. I'm going to have to look into this. This is the second time this has happened on the consensus model. But here we got the consensus from Llama 3.1. After reviewing the responses, I've identified some common themes of points of agreement. That it's DHCP offer, packet source and destination, the protocol stack, the message type, and the checksum. There's some differences and discrepancies. And here's the synthesized answer from Llama 3.1. Now we have Mistral summary. Again, very similar, and it has all of this information. Qwen summary. Now, even though Qwen hallucinated the first time and didn't really give us an answer at all, it's able to participate in the consensus, seeing the other AI's answers. So it does now pick up that it's DHCP. And then the 5.4 consensus. Very cool. Now, this is even really powerful, is the very, very small DeepSeek model's consensus answer, which is now starting to pick up cues from the other answers and the common themes and some open question for further analysis. Now, it's still doing the final consensus. We'll let this finish. It's still running here, and it's probably still in maybe my Gemma container. Yeah, it's still in the GPU. So we'll let it come to the final consensus, and then we'll try another packet. But I'm very, very pleased with these results. Aside from maybe the Qwen model, which we may have to remove from the stack and find another open source model to replace Qwen. So we'll be back in a few more minutes. Okay, so everything's finished up, and you can see that we're at the final consensus from Llama 3.1. Carefully reviewing all the summaries, I've identified the most compelling arguments and integrated the best elements from each perspective to arrive at a unified conclusion. And, DHCP offer, packet contents, timestamps, server information variability, open questions for further analysis, and some final analysis here, some recommendations, and the unified response. So there's Mistral, comes to similar conclusions, has different details. There's Qwen. Again, I'm thinking of dropping the Qwen model. 5.4 has some really great stuff and breaks it all down here for just, 14 billion parameters. And then finally this DeepSeek, which is a very, very small language model, comes to some final conclusions. So what we're going to do next is refresh the page and do something a little more complicated. So let's grab, where is it? I thought I had a different, let's grab the BGP packet. And we're going to proceed to chat. And just to show you what this packet capture looks like, so we're all looking at, the real raw information. It's a standard TCP BGP flow with, port 179 and a source and a destination back and forth between these two IP addresses. But it's all BGP information. If we look a little bit deeper here into the port numbers and the information being provided, this is all BGP. So we're going to say, what can you tell me about this packet capture? Assuming we don't know anything about it at all, can we get these AIs, again, 6 different AIs. I'm still using Qwen. I haven't dropped that model yet. We'll do that later. But can we at least get them to come to consensus that this is BGP information and that there's BGP flows between them? All right, I'll come back once we have the initial batch of answers. Okay, we're back with the final analysis and each individual analysis. Just for reference, we're dealing with 192.168.0.33 source and 192.168.0.15 destination using port 179. All right, and vice versa. They kind of interact through BGP. So Gemma 2 doesn't explicitly call out BGP, but it does get the IP and port numbers and sequence numbers and all this other stuff correct. Llama 3.1 might be related to a BGP session establishment, which is correct. It gets the IP addresses correct and initiates a BGP session. Now Mistral, does Mistral call out BGP? I don't think it does, but it has all of the information factually correct. Here's Mistral, sorry. And then Qwen kind of hallucinates, doesn't quite get anything right. Again, we have to reevaluate whether Qwen belongs in this Council of Oracles or not. Now 5.4 really breaks it all down with all correct information, and I don't think it comes to a conclusion of BGP though. So it's interesting. It's not recognizing BGP here. And let's take a look at the final analysis from DeepSeek, the small language model. Source and destination MAC is correct. Port numbers are correct. Flags. Now it does not come to the conclusion about any BGP information. I've got a couple timeouts here, so some of this consensus isn't going to be that great. But let's just see about some of the final conclusions here. A little bit of hallucination. Although the final answer here, yeah, because of the timeouts, it's kind of poisoned the information. But we do have some pretty good packet analysis from these open source and free models. So I'm going to stop here. We've analyzed DHCP, BGP, a single packet in the previous video, source and destination IPs. What can you tell me about this packet? The Qwen model doesn't perform as well as the other models. So moving forward, we're going to maybe find a substitute or just remove that model from the Council of Oracles. And this is very promising. On an RTX 2060, a council of artificial intelligence, small language models, and large language models coming together to come to consensus on the best answer to improve trust and quality. All right, stay tuned for more.